Okay, ma'am. Thank you. Okay. So let me start with today's session. So we are going to see on the topic called regression algorithm. So far we are coming up with the machine learning algorithms. So in the last three sessions, we have deal about the classification algorithms. Okay. So under the classification, today we are going to see the regression algorithm. Okay. So there are two kinds of regression algorithm that we are going to see in today's session. That is linear regression and logistic regression algorithm. So the objective of this session is to make you know about the basics of regression algorithm, and the outcome of the session is the students will be able to understand the concepts behind the regression algorithm. Okay. So these are the agenda of today's session. So let's start with the introduction about the machine learning and the types involved in machine learning, and the comparison between the classification algorithm with that of the regression algorithm, and we'll be seeing what is meant by regression, a linear regression algorithm, and next we'll be continuing with that, we'll be seeing what is logistic regression, and we'll be seeing the linear regression use case and the logistic regression use case, then winding up with the comparison between the linear and the logistic regression, and we'll be seeing the applications involved in linear regression. With that, we'll wind up the session. Okay, and these are the outlines. Just now we have seen with the diagrammatical agenda. So, okay, what is machine learning? We'll be dealing with that, and the introduction to machine learning, and what are all the process involved in machine learning, what are the types of machine learning. Then we'll be comparing with the regression and the classification algorithm. Then we'll be seeing what is meant by regression, what are the uses of regression, and what are the selection criteria or possible or used for linear regression, and how comes the linear regression emerges into, that is history of linear regression. Then we'll be seeing what is meant by linear regression, where we can use this linear regression, and how we can implement this linear regression, and what is meant by logistic regression. Then we can go for comparing the linear regression with that of the logistic regression. Then we can wind up with the applications of linear regression. Okay. Okay. So what is machine learning algorithm is that we are going to make the computers to learn, and so that it is going to act like a human. So with the help of providing some input data and information without being explicitly programmed. So this is what called machine learning. Okay. So in this you can clearly see from the past data, you are going to analyze the past data and train the model or the train the machine, and so as to predict the accurate output. Okay. Okay, so here you can see a best example. So based on the amount of rainfall, you could predict the crop yield. Okay, okay, this is the problem given to you in order to predict the crop yield. So this crop yield will be depending on the amount of rainfall. Okay, so here you can see clearly what are all the dependent variables and what are all the independent variables. So dependent variable is going to be have the output, that is your outcome or the class, or in other words you can say it is a target, outcome, or labeled class, like that. Okay, so that is your dependent variable. So always the output will depend on the input variables. So we call input variable as a independent variables. So here, so this output variable crop yield, this is your dependent variable, will always depend on the independent variable, that is the amount of rainfall. Okay, so this rainfall is going to be called as the independent variable. Fine. See here, the variables are classified as independent variable and dependent variable. So independent variable means a variable whose value does not change. Sorry for the inconvenience. Let me continue with the where I have left. Okay, let me share my presentation. Is it visible?
Yes, ma'am.
Okay, ma. Okay. So far we have seen the classification of variables as dependent variable and independent variable. We can also classify the data as numerical and categorical. So numerical will be numbers format. For example, you can take it as a age, salary, height. For coming on to the categorical, the values will be characters. Okay. For example, you can have the color values as red, green, like that. Dogs, breed, gender, and you will also have the categorical values as yes or no, true or false, zeros and ones. Okay. So this is all about we can classify the data as numerical and categorical. Okay. So coming on to the processes involved in machine learning, so there are seven processes are there. First, it starts with the data gathering and it will move on to the data pre-processing, that is removing the noises and the outliers from the collected data. Okay. And choosing the model is nothing but choosing which algorithm to apply. Okay, whether the problem may be a classification problem, or it may be a clustering problem, like that. So based on that problem, you have to apply the corresponding algorithm to it. So that is what choosing the model. And you have to go for training the model with the training data sets given to the user, and testing the model is nothing but validating the uh, design, that is classifier model, like that, validating with the given new test case, new data sets. Okay, and tune the model. What is tune the model is nothing but tuning the parameters, that is changing the parameters. You would get better accuracy or better performance of the model. Okay, so that is called as tune the model. So finally you will get the prediction. Fine. Okay, so already we have deal with the types of machine learning algorithms. It is classified into three types. One is supervised learning, the other one is unsupervised, and reinforcement learning. Okay, so here you can the type of machine learning is picturized here. So from the picture itself, you can easily keep it in mind that what is meant by supervised, unsupervised, and reinforcement. Okay. So coming on to the supervised learning, the machine learns under guidance. Okay. So like the teacher teaches or guides the students. Okay. Similarly, the machine learns from the labeled data. So that is explicitly telling that you'll be given the input data. Then the user has to uh, say how the output should look like. Okay, so here the teacher is nothing but the training data set. Okay, so coming on to the unsupervised, so the example for supervised learning is classification. Okay, classification. Next, unsupervised learning algorithm means here you won't have any labeled data and no guidance. Okay, so see, the boy is learning by himself. Okay, so he has to act accordingly, and he has to learn from the past experiences. Okay, so the machine has to figure out the data set given in case of unsupervised learning. So it should find the hidden parts in order to make the prediction about the outputs. So that is what about the unsupervised learning. So no guidance will be there, no labeled data will be there. So it has to make the predictions about the outputs from the given data set. Okay, so for example, clustering. So clustering means you have to group the classes based on the similarity. Okay, so clustering, association, rule mining, all these comes under unsupervised learning. Okay, fine. So coming on to the reinforcement learning, let's say you have dropped out on a isolated island. Okay, so guys, what you do initially, you would panic and you would be unsure what to do and where to get the food, where to get food from, and what to eat and how to live, and so on. So many questions arises in you. Okay, so but after a while you have to adapt to the climate, adapt to the environment. You have to learn the environment, how to live in this island, like that, and so on. Okay, so you'll be learning what to eat and what to not eat. So basically what we would do is following the hit and trial method. That is in other words we can say trial and error method. Okay, see, because you were new to the surrounding, and only the way for you to learn from the experience. Okay, so this is a reinforcement learning is a learning method wherein which the agent interacts with the environment and reducing some actions and discovers rewards and errors. Okay, so doing some actions, the agent would be getting some rewards. So that's all about the reinforcement learning algorithm. Okay. So here you can have the what are all the problems you can go for applying the so and so machine learning algorithms. So in case of classification, you can go for detecting the problems like fraud detection, email spam detection, image classification. So for all those kinds of problems, you can apply the classification algorithms. And coming on to the regression, you can go for weather forecasting to predict the weather, then risk assessment, score prediction. For all these such kinds of problems, you can apply the regression algorithm. Okay, coming on to the unsupervised learning algorithm, that is best example is clustering and association. So in the association, the examples are market basket analysis, text mining, face recognition, also comes under association rule mining algorithms. Okay, and coming on to the clustering algorithm, you will be having the problems like medical research problems, city planning, targeted marketing problems. We can go for using the clustering algorithms. Okay, and the next one is reinforcement algorithm. We can go for applying the gaming problems, robot navigation, stock trading, assembly line processes. For those kinds of problems, you can apply the reinforcement learning algorithms. Okay. So today we are focusing on the regression part. Okay. So machine learning, as we all know, machine learning is classified into three types: supervised, unsupervised, and reinforcement. And this supervised learning is have a two categories, that is classification and regression. Okay, so now we are going to see the regression part alone. Okay, so before moving to the regression, let's have a comparison between what is meant by regression and the classification. Let's compare these two. Okay, so classification means it is the task of predicting the class label, the discrete class label, whereas regression is the task of predicting the continuous quantity. So, classification is going to predict the label, class label, and regression is going to predict the continuous quantity. Okay. So in the classification problem, the data will be classified into two or more classes. Okay. So we can divide the classification problem into two kinds. One is binary classification, the other one is multi-class classification. For example, if you take the mail, the problem given to the user is to predict whether the given mail is spam mail or non-spam mail. So if this is the problem, the output class is of 2. That is spam class or non-spam class. So this is an example for the binary classification, since you are having two classes. Okay. So if the problem is having more than two classes, then we call that classification problem is a multi-class classification problem. Okay. Okay. Coming on to the regression part, it is the task of predicting the continuous quantity. What is meant by continuous quantity? So continuous quantity is basically a continuous variable. So continuous variable, what do you mean by that continuous variable? The variable that has infinite number of possibilities. For example, you can take up a person's weight. It may be 80 kg at one period of time, or it may be 40 kg or 180, 50 kg. So when the age increases, the weight also increases, like that. Okay. So the number of possibilities for weight is limitless. Okay. So this we call it as exactly the continuous variables. Okay, so in regression, make a note of that. In regression, we don't have the labeled data into different classes. Fine. So regression, it won't be like the classification problem. Okay, so the regression problem requires the prediction of a continuous quantity. The regression problem with the multiple input variables, we call that as a multivariate regression problem. So take here in this picture, we can easily find that the price of a stock, to predict the price of a stock over the period of time. If the problem is given like that, you can make use of the regression algorithm by studying the relationship between the dependent variable and the independent variable. So here the dependent variable is going to be their stock price and the independent variable is going to be the time. Okay. So the price of the stock is the dependent variable. So it varies over a period of time because the stock price is dependent on the some other variable that is dependent on the time. So it is price is called as a dependent variable. Okay. So make a note of a important point that always the dependent variable for a linear regression model is always continuous. Okay. So the price of the stock is going to be continuous because it can have the infinite possible values. So the price will be varying based on the value of time. So it can have a possible number of values, infinite possible number of values. So we call the price of stock, that is the dependent variable, will have the continuous quantity. Fine. So here the time is called as the independent variable. So independent variable means it can be a discrete or continuous. Okay. So this is what the difference between the classification and the regression part. Okay, coming on to the regression, it is been classified into three types. One is simple linear regression and multiple linear regression and polynomial linear regression. So already, even though it's having three classification, by default we can classify the regression as two types. One is linear regression and the other one is logistic regression. So today in this section, we'll be discussing what is in the linear regression and what is in the logistic regression, where we can apply these kinds of problems. Okay. So before moving to the linear regression and logistic, we'll deal with what is the regression problem. Okay. So regression analysis means it's a form of predictive modeling technique. So it is nothing but the prediction. Okay. So which investigates the relationship between the dependent variable and independent variable. So what is regression is all about the prediction is based on the two relationship, that is the relationship between the two variables, that is independent and dependent variable. So what are the uses of regression means there are three major uses of regression analysis. They are determining the strength of the predictors and forecasting. In forecasting problems we can apply this regression algorithms, and for trend forecasting also you can go for up to real-time trend analysis. We can also use this regression algorithms. So what are the selection criteria to holds good for the linear regression means classification and regression capabilities, data quality, computational complexity, comprehensible and transparent. So these are the selection criteria to which we can apply the linear regression algorithm. Okay. So how the linear regression comes into picture, that is we can have a look over the history. Okay. So linear regression was introduced by the person called Francis Galton. He studied the inference from the that is you can take up an example from the heights of a father and son. So these heights are measured or analyzed. Okay. So we'll get some collection of data about the height in centimeters. Okay, fine. And the regression line is drawn on the collection of the height data. Okay. So with the collection of height data, the task is to best fit line in this collection of data. Okay. Then finding the mean height of all people, you will get the linear regression thoughts. Okay, we'll see that. Okay. So linear regression means it's a method to predict the dependent variable y. So y is called as a dependent variable, and this dependent variable is predicted based on the independent variable values, that is called as x. So y is predicted based on x values. Okay. And it can be used for cases where we want to predict some continuous quantity. Okay. See here, the linear regression is a statistical model used to predict the relationship between the independent and the dependent variables. Okay. So this linear regression examines two factors. The first factor is which variables are particular or significant predictors of the outcome variables. So first task is to identify which one is the dependent variable and which one is the independent variable. So always the linear regression, in the linear regression the dependent variable is going to be having the continuous values. Okay. So you have to make a note of that point. Okay. And the second factor is how significant is the regression line to make the predictions with the highest possible accuracy. That is the second point to be considered is that the regression line is to be drawn. That line should best fit on that particular plotting. Okay. So we'll see linear regression is a method to predict the dependent variable based on the values of independent variable x. It can be used for the cases where we want to predict some continuous quantity. Okay. See this plot. The plot is going to be between the independent variable x and the dependent variable y. Okay. So what is called as dependent variable y? So the response variable. So dependent variable is otherwise called as response variable whose value needs to be predicted. So that is your outcome. So y is your dependent variable, that is your outcome or output. Okay, that is your response variable. So that is the value to be predicted. So independent variable means it is called as a predictor variable. So this predictor variable is used to predict the response variable. So always this independent variable, with the help of the independent variable, it needs to predict the values of the dependent variable. So we call that x as a predictor variable and y as a response variable. So the following equation is used to represent linear regression model. Y equals b naught plus b1x plus e. Linear regression, we'll see how the linear regression works. So this linear regression will works out or figure out the relationship between the dependent variable and the independent variable by using a best fitting straight line. So you need to draw a straight line between the independent variable and the dependent variable y. So y is your output, okay, and you need to draw a straight line. So that line should fit that particular model, that best fit their particular model. Okay. So now the linear regression is called as a simple model because it takes only two variables, that is independent variable and the dependent variable. Okay. So in this case, the linear regression will try to establish the relationship between the independent variable and the dependent variable. So the reason for a linear regression is called linear because both these variable, that is dependent variable and independent variable, is very linearly with respect to each other. So basically, so far we have seen one example that stock price and the time. So these two variables, stock price is your dependent variable, that is your output, that is your y variable, and time is the x variable, that is the independent variable. So these two are linearly dependent on each other. So by plotting the relationship between the two variables, we have to observe the straight line instead of a curve because of the linearly dependent in nature. Okay, so next we'll see the discuss about the mathematical behind the linear regression. So the formula to calculate is y is your dependent variable, that is the outcome or that is the response variable, that equals b naught plus d1 plus d1 into x plus e, where e is the error and x is your independent variable and b1 is the slope of the line and b naught is the y-intercept and y is the dependent variable. Fine. So this is the formula used to represent the linear regression model, or this is the equation used to represent a linear regression model. Okay. So this equation is used to draw out a relation between the independent variable x and the dependent variable y. Okay. So here you can see the errors. Okay, so this is your straight line drawn between x and the y. The task is to the line straight line. We call this straight line as a regression line. This line should best fit the model. Okay, okay. The slope is so y-intercept is the line, the point at which the line intercept the y-axis. That we call it as the y-intercept b naught. Okay, and b1 is the slope. So for this we will be using the linear equation. As we all know, the linear equation of the linear line is y equals mx plus c, where m is the slope and c is the constant. Okay. So the slope of the line may be linear line b1 can be of two type. One is the positive slope or it can be a negative slope. So this positive slope and negative slope will depends on the relationship between the dependent variable and the independent variable. So based on the variables, the slope might be positive slope or negative slope. Okay. So coming on to where we can use this linear regression is that for evaluating the trends and sales estimates, we can apply the linear regression, and for analyzing the impact of price changes, and for the assessment of risk in financial services and insurance domain, we can use this linear regression. So just now we have seen the linear regression equation, that is y equals mx plus c. Okay, so this is the simpler form of linear regression equation with one independent and one dependent variable is represented by y equals mx plus c. As we all know, y is the dependent variable, that is the response variable, that is the output variable, and m is the slope which is calculated from the formula y2 minus y1 divided by x2 minus x1. As we all know, how to calculate the slope of the line. Okay, and x is the independent variable and c is the coefficient of the line. Okay. So the first example, what we have seen in the first example, the crop yield is the dependent variable. So we have to predict the crop yield based on the rainfall values. Okay, so here rainfall is the independent variable and dependent variable is crop yield, and we have to plot the amount of crop yield based on the amount of rainfall. Okay. So here in the second picture, you can see the red point and the green point. So red point is on the y-axis and green point is on the x-axis. Okay. So the red point on the y-axis is the amount of crop yield can expect for some amount of rainfall, x represented the green dot. Okay. And a regression line is drawn between the x and y so that it should best fit the particular model. Okay, let's see how the concept behind this regression line. So how we are drawing the regression line. So in the previous slide we have seen that a regression line is drawn between the x and y. Now in the next coming slides, we have to we are going to see how this regression line is to be drawn. Okay, so consider you are given a sample data set having 5 rows. Now the task is to draw the regression line. Okay, so see here 5 independent variables are there. X values is the independent variable and Y variable is the independent variable. So we are having 5 possible rows with the values. Okay, so now plot these data points. So each x comma y value is, we call that as a data point. Now plot these value between the on the x-axis you will be having the independent variable, and on the y-axis you will be having the dependent variable. So 1 comma 2 plotted. So on x 1 and 2. So the first data point is plotted, and for the second one 2 comma 4 it has been plotted here. 2 and 4 here. Okay, and the third one is 3 comma 5. 3 on x-axis and 5 on the y-axis. 3 comma 5 is plotted. 4 comma 4 is plotted here, and 5 comma 5 is plotted here. So with the given x and y values, a graph is drawn between the independent variable and the dependent variable. Okay, so what is the next task we need to do? Find the mean of x and y. Fine. So you're getting the mean value of x and y as 3 comma 4. So where it is plot the 3 comma 4, you will be getting this point. Okay, okay, so draw the line intersecting 3.4. Fine. Now what to do? Draw the equation of the regression, drawing the equation of the regression line. So as you know, all know, y equals mx plus c. Okay, so what is the formula to calculate? The m is here and the c formula is here. Okay, so you need to go on predicting the values x square, y square, x into y, and the summation of all the values. In order to substitute all these values in these formula, you have to tabulate all these values. Okay, so we are getting the m value as 0.6 and the c value as 2.2. So substitute the values of m and c in y equals mx plus c. You are getting the y value as 4. Fine. Okay, now what to do? So the y value is so what is the formula? mx plus c. Okay, so the m value is 0.6 and x value you have to go with finding what are the x values you are having. 1, 2, 3, 4, 5. So with that value plus c value is 2.2. Okay, so with that find the value of predicted y value. Okay, you'll get 2.8, 3.4, 4 and 4.6 and 5.2. So see this picture. First the data points that is blue points represent the actual y values. Fine, and the brown points represent the predicted y values. So the predicted y values are here: 2.8, 3.4, 4, 4.6 and 5.2. Okay, so now the distance between the actual y value and the predicted y value, we call that as a error. The other name for errors is residuals. Okay, the best fit line should have the least sum of squares of these errors, which is also called as E square. Okay, so after plotting the x and y values in the graph, we need to go for finding the mean values of x and y, and with that mean value draw a straight line on the graph, and you need to go for finding the substitute the values of mx plus c value. With that y value you need to go for finding the predicted y value. Okay, so you'll get the predicted y value. Now find the difference between the actual y value and the predicted y value. So the distance between these two, we call that as a error. Okay, and the error should be, that is how far we have to draw this regression line. The best fit line should have the least sum of squares of these errors. Okay. So we are getting 2.4, least square value is 2.4. So the sum of the squared errors for this regression line is 2.4. Okay. So our ultimate aim is that we have to draw the best fit line, that is called as a regression line. The line should have the minimum distance between the data points and the regression line. Okay. So minimizing the distance, that is you have lots of ways to minimize the distance between the line and the data points, like sum of, you can go with this ways, that is finding the sum of squared errors, sum of absolute errors, root mean square, like that. So based on these ways, you can find or you can choose any one of the ways to minimize the distance between the line and the data points. Okay. So we can keep moving this line through the data points to make sure that the best fit line has the least square distance between the data points and the regression line. Okay, so already we have know that the regression is classified into simple linear regression and multiple linear regression. So for the simple linear regression, the linear equation to be used is y equals mx plus c. And for the multiple linear regression, you have to go with using the formula, that is y equals m1 into x1 plus m2 into x2 plus m3 into x3 goes on with mn, xn plus c. So where c is called as the coefficient and m1, m2 are all the slopes of the line, and y is the dependent variable and x1, x2 are the independent variables. Okay. So linear regression is a linear modeling approach to find the relationship between the dependent and the independent variables. Okay. And the independent variable we call that as a predictors, and the dependent variable y is called as the target, that is your response variable. Okay. So can have the problem like predict the sales of ice cream based on the temperature. For this, you can go for applying the linear regression algorithm. So they can go for plotting the values between the sales and the temperature. So sales of the ice cream based on the temperature, and you can go for drawing the regression line between the sales and the temperature to predict the sales. Okay. And you have to go for finding the best fit line also. The best fit line can be found out by minimizing the distance between all the data points and the distance to the regression line. Okay. So in this picture, this is not a best fit because the distance between the data points and the line is maximum. So here the data points and the distance is so maximum, so we cannot choose as a best line. So in this picture, this is also not a best fit line because the distance and the distance between the data points and the line can still be reduced. In this case, you can state that the blue line is best fit regression line because the distance between the data points and the line is very least one. Okay. So another case study, that is to forecast the monthly sales by studying the relationship between the monthly e-commerce sales and the online advertising cost. So here you are given a data set. Okay, so here the monthly sales are the dependent variables, that is your final output. Okay, and the independent variable is advertising cost, that is your x value, and y value is monthly sales. Okay, so you can go for plotting the graph between the independent variable cost and the dependent variable monthly sales. So you have to predict the monthly sales based on the advertising cost. Okay. So the linear regression can also, the another example, you can go for predicting the employee's salary based on the years of experience. Suppose if a new joinee or new employee is joining a company. Okay, consider that a situation. The company would decide how much do they pay for the new employees. Okay, the HR team is trying to figure out how much to pay for a new employee. Okay, so here you can have a plot between the years of experience and the salary. So based on the experience, the salary can be given. Okay, so employee data of salary will be based on the years of experience. So predict the salary based on the experience. Okay, so this is what all about the linear regression. Now moving on to the logistic regression is a classification algorithm used to predict the categorical values. Categorical values means it is like a yes or no value or true or false values or 0 or 1 values. Okay, so who will default on their credit card payment? You can take up this example. So credit card users will be there, make a credit card transaction, and you are going to find the plot between the balance and the income. That is the plot of the monthly credit card balance and the annual income. Okay. So here you can have a plot for the logistic regression. So far we have seen the plot for a linear regression. So there we have to draw a straight line that we call it as the regression line. That line should best fit the model. So in case of logistic model, the logistic regression curve will be plotted. Instead of straight line, here the curve will be drawn. That curve is called a sigmoid curve or otherwise called as S curve. Fine. So instead of straight line, y equals linear equation y equals mx plus c, we would draw a sigmoid curve like this in the second picture. Okay, see here in this second picture, you can the curve is drawn between 0 and the 1. The value will lies between, that is the predicted output value y lies in the range of 0 and 1. Okay. So how to plot this logistic regression curve? So between the 0 and 1, you can go for setting up the threshold value. Fine. So the threshold value, or you can take it as a cutoff point at 0.5. Okay. So anything below the cutoff point or threshold value will result in 0. Anything above the 0.5 to 1 will be belong to the 1. Okay. So here in the second picture, you can you are having the red data point, which is will default as it is above the threshold value. So here is your threshold value, that is 0.5 is the threshold value. The red point is above the threshold value of 0.5, and the green point is below the threshold value. That is 0.2 is having it's mentioned as below the threshold value 0.5. Okay. So for the logistic regression, you need to go with the equation for the regression model, log of y divided by 1 minus y, that equals c plus b1 x1 plus b2 x2 and goes on. So this is the formula to holds good with the logistic regression. So what is the main motive of logistic regression? Is a method to predict the dependent variable giving the set of provided the independent variables. So the important point to be noted for the logistic regression is that always the dependent variable in logistic regression would be categorical, whereas in the linear regression, always the dependent variable will be continuous variable. Here, logistic regression, the dependent variable will be categorical. Okay. Fine. So categorical means yes or no, or particular true or false, or 1 or 0. Likewise. So the dependent variable y, we call that as a response binary variable because the value would be either 0 or 1. Okay. So we call that as a binary variable. Okay, and yes or no or ABC like that. Okay, coming on to the independent variable, that is X variable, and we call that as a predictor variable used to predict the response variable. Fine. So you'll be getting a S-like curve that we call it as a sigmoid curve. Okay. See, the range of values is going to be between 0 and 1. So for the logistic regression, the outcome value would be ranging between 0 and 1. Okay. So let's know behind the mathematical equation behind the logistic regression. Okay. So we won't find a linear line here. Instead of a linear line, we'll be having the curve that is called as S curve or a sigmoid curve. So this sigmoid curve will maps the relationship between the dependent and the independent variable for logistic regression. So the logistic regression only calculate the resultant outcome between 0 and 1. So why do we have this curve from 0 and 1? Why it's not having the straight line at 0? Sorry, it should be having the straight line at 0 and straight line at 1. So this is because the output values will calculate the outputting the values between 0 and 1 in the logistic regression would calculate the probability. Okay, so let's say that the final probability of an event occurring is 0.6. So what does this mean? Does the output belongs to the class 0 or class 1? So how we have to predict is that, so when we face this such a situation, we have to go for setting the threshold value. Let's say, let us take the threshold value as 0.5. This means that any value in this range of 0.5 will belong to the, that is 0.5 to 1 will be classified as 1. And below 0.5 will be classified as 0. So in this way, we can easily get a binary resultant variable. So Y ranges from between 0 and 1. Okay. So it can have the positive slope also, or otherwise called as positive correlation. Meaning that when the value of monthly sales before example, we have taken that monthly sales and the we have to plot the graph between monthly sales and the advertising cost. So whenever the value of advertising cost increases, the monthly sales also increases. Okay, so this graph will use to plot to predict the future sales. Okay, let's have a comparison between linear regression and logistic regression. So far we have seen linear and logistic. So taking up the definition part, linear regression will always predict the continuous dependent variable based on the independent variable values. Okay, and coming on to the logistic regression, it is used to predict the categorical dependent variable. So make a note, regression, it will find the continuous dependent variable, and logistic, it will predict the categorical dependent variable. Okay, so coming on to the variable type, linear regression will be always having the continuous dependent variable, and for logistic regression it will always have the categorical dependent variable. So the estimation method for the linear regression will be followed least square estimation, and for logistic it would follow the maximum likelihood estimation. And the equation to be followed for linear regression, y equals b naught plus b1x plus e, and this is the formula for logistic regression. Okay, the best fit line will be straight line in case of linear regression, and S curve, that is sigmoid curve, in case of logistic regression. And relationship between the dependent variable and independent variable in the linear regression, there will be a linear relationship between the dependent and independent variable. That is, what does this means? The dependent variable and the independent variable will have the linear relationship. That is, whenever the independent variable increases, it will also, there will be a linear increase in the independent variable also. So in case of logistic regression, that linear relationship is not a mandatory one. Okay. So the output in linear regression will be a predicted integer value, whereas the output in logistic regression will be a predicted binary value 0 or 1. Okay. The output will be between the 0 and 1 value. Okay. So coming on to the applications of linear regression, it can be applied on the business domain, forecasting sales, and the logistic regression applications will be classification problem, cyber security problems, and image processing. Okay. So far we have seen this differences. The same thing is depicted here. See here, the accuracy and the goodness of the fit is computed in linear regression with the help of measured by loss R squared, adjusted R squared. Okay. And in case of logistic regression, we can compute the accuracy, precision using these all the methods, precision, recall, F1 square, ROC curve, confusion matrix. So these are all the performance measures that you have seen in the classification session itself. Okay, in the prior session we have dealt all these such kinds of performance measures. Okay. And these are the applications of linear regression. It is used to predict the economic growth, which is to predict or determine the economic growth of a country or the state in the coming quarter, years, or can also be predict the GDP of a country also. And you can also predict the product prices. What would be the price of the product in the future? Okay. And it is also used to, linear regression is also used to estimate the number of houses a builder would sell. Okay. And at what price the builder would sell the particular house. So that can be predicted in the coming months. Okay. And you can also predict the number of runs a player would score in the coming matches based on the previous performance. The score prediction can also be done with the help of the linear regression. So with this, I'll wind up the today's session. So today session we have seen what is the difference between the classification and the regression, and what are the types involved in regression, that is a linear regression and the logistic regression. And we have compared, we have seen the comparison between the linear regression and the logistic regression. And we have seen the application of the linear regression. With this, I'll wind up today's session. Thank you all for patient listening. Thank you, Tarani. Thank you, ma'am.